payback period, which will give you a rough idea, show you the liquidity, how fast the initial investment can be recovered. They have a lot of weakness, but it's still a common one. We're going to skip these two, discounted payback period, and particularly the average accounting return method. Those are not very useful in real world. So we will skip 3, 4, and go directly 1, 2, 5, 6, 7. And I also want to show you what the practice in real market will be. Okay. First, let's look at net present value. A net present value is basically, it's very intuitive. It basically says that you use all the cash flows. We have two types of cash flow. One is cash inflow. The other one is cash outflows. You look at all the cash flow and then list them together and take consideration of different time horizon and take looking at and then discount it, those cash flow according to its risk. What that means? That means high risk project, you're using high discount rate. Low risk project, using low discount rate. And then you're looking at what the net result is. Now if it's positive, that means that project, so-called making money. If it's negative, it means this project is losing money. They are all hypothetically compared at today's dollars. And the rule says you accept it when it's positive. Now, the present values are, because it's a total investment, is a total cash flows, all cash flow included. So you have to estimate the future cash flow, you have to estimate discount rate, and you also estimate initial cash outflows. So what we do here is basically looking at a situation look like this. Initial cash outflows, I put it using 0 represents initial cash outflows. Then we have cash inflows. Cash flow 1, cash flow 2, up to cash flow n. 1, 2, up to n. Now, the net present value, what we do is let you calculate the present value of all those future cash flows and add them up. The net means positive minus negative. Yeah. Looking at everything in today's dollars, and the rule says this should be positive or non-negative. Now my argument is even it's break even, net present value is 0, we're still going to take this project. Only when it's negative means you are losing money, then we reject this project. When you do that, the market will reward you. Your company's stock will move up. This is what the basic idea is. Now this is the acceptance criteria. Now if you have multiple projects, 1, 2, 3, 4, how do I rank it? Higher the better. If you only choose one, you choose the highest one. So it's a multiple project. If you have enough money to take them all, it's all positive. But sometimes you are limited in your budget. Then take the highest net present value. Now let's just looking at the example just by hand, what that means. Here is a typical project is involved with the multiple cash flow. Here is 4 cash flows. Initial investment $200 represents cash outflow, initial investment. The future investment is 50, 100, 150. And the discount rate is 8%. Here we use discount rate represent cost of capital, 8%. What net present value is, just using present value plus present value 50. We discounted it back. Right? Discounted it back. Discounted back. Now, before we study the CF key, we're using future cash flows. So here is future cash flow 1, future cash flow 2, future cash 3. You have to do 3 separate times. But with the financial calculator, we can use this one as our function. Now let's do this together. We're going to use this one. We do this together. Using this key, CF key, to key all those numbers in. Okay? So the first one you punch is CF key. They will ask me what is CF0 is. Usually it's cash outflow. Here, in our situation, is 200. You have to change sign, negative. Then please using enter. You have to punch enter so it's registered. Enter. See that? Now please follow this as I do together with you. Enter. So next one we'll enter next key. We're using the arrow key. See the arrow key here? Arrow key. When you punch arrow key, you're asking what is CF key 1? Here is 50. So 50. You have to enter it. Enter. Enter. So register this one. Now, when you move, the first one you hit one, it's asking you frequencies. How many 50 you have? By default is 1. By default is 1. If you repeat it with 2 or 3, 4, but here only 1. So we move further. One more key, CF2, which is 100. Enter. F2, by default, move further, F3. Now F3 is 150. Enter. Now you can using the arrow key to check all the number you enter in. CO3 150, CO2 100, CO 150, CF0, initial cash flow negative 200. So you enter all the key in that CF key. We cannot really see it. Okay. Spreadsheet will allow us to see all those cash flows much easier. The next one we do is calculate net present value. Now see, I'm going to using this key. When you put everything in CF key, then punch NPV. When you punch NPV, first they ask you what is the interest rate. Here is 8%. 8%, enter, you have to enter it. 8% you enter it. Then using arrow key, move down. Net present value you calculate and compute. So the result is 51.11. Now, the conclusion is we accept it because it's holiday. It's a holiday. So it's pretty straightforward using CF key, enter all those numbers, and using the arrow key, to move from each cash flows. Okay. This is what the cash flow key will do.
So after the CF3, what do you
Yes.
punch in after that?
After CF3, you don't need to punch anything. You go to net present value. You go to NPV key. Then you need to enter interest rate. Then you compute for NPV. And you compute for NPV. So I'm going to show you, let's do it again. This time, just want to change one, okay? Instead of a 500, let's change this one to 200. Change to 200. Now let's just do it again. Do it again. How do I do that? Now, first, you go to CF key in. Every time you enter the key, you need to clear memories. Now, we're no longer using the second and clear time value money. You have to use using second clear work. You have to in the CF key to second clear work. Please make a note on it. You have to clear all the register, all the number. Now, if I'm using just clear, for example, if I'm just using clear, right? It won't clear. Inside is still in it. You have to use second clear work. Everything's gone. Inside, everything's gone. Okay? Now let's try, this time I'll give you some kind of different number to see how it happens. Okay? Let's put some new numbers. Just for fun. Investment, let's say 500. This one is 200. 200. And this one is 400. Interest rate still 8%. Calculate its net present value. Now this time, first you need to clear everything. Clear work. Now when you put the first one negative 500, everybody put it in? Okay, move, enter, then move down.
So is the interest discount right there?
8%, yes. Now this time, since I give you 200, you can enter CF1 200, enter. Then you need frequency to 2. You don't have to repeat enter it twice if it's continuous. Because you can like frequency twice. 200, okay? But the 200 you cannot just like a 200 after that you cannot do it. You must have it one after other. Continuous. Consecutive. Yeah, continuous.
So what do you put in CO2 then? Does that
CO2 become here become 400.
Okay.
Yes. But in that case, all right, now let's go to NR. Get NPV, net present value. Interest rate is 8%. Enter. Down arrow P, compute. What do you get? What is the result? Net present value? 174. So still positive. You accept or not accept? You accept it. Okay. You accept it because you're still making money. Right? Now, so you have to be careful in CFQ using second and clear.
I did something wrong.
You did something wrong. You didn't clear. Sandra, I'm pretty much sure. Pretty much sure it's the problem clear.
No, I did clear.
Okay, let's do it again. I'll wait. 500, change sign, enter, error key.
So after the
CF 500 minus
after the 8 you do enter, right?
Yeah, enter, yes. Then move down.
Down.
Compute.
Oh, move it down, compute. Okay.
Yeah, there is no logic there. This one, there's no logic. You have to remember. I'll do it again, okay? So on this time, I'm going to do it again. First one is 500, change sign. Right, enter. Next one, CF1 is 200. Enter. Now here I'm kind of lazy. Since that 200, I'm using frequency equal to 2. Enter. Okay? Then the next one, although it's telling me CF2, actually CF3. Because the previous you doubled it. But this one is 400. Enter. So I go to NPV, interest rate is 8%. Move down. You have to use move down. Then using compute.
Did you push NPV before you put in the interest rate?
Yes. Otherwise it won't work.
So you push it.
NPV, push NPV.
Okay, says
Then I, then you enter 8.
And then enter.
Why do you just 8? Just put 8 in.
Okay.
Enter. Then using arrow key. Then compute. The sequence doesn't make a lot of sense. You have to like write it down, make a note. You can repeat my procedure. The frequency does not make a lot of sense.
Arrow is
using
missing
arrow.
the down. It's missing the last down arrow.
Yeah. The error. There is an error you have to remember, punch it. Are you okay?
Yeah, thank you.
Okay?
Yeah.
So what was the answer?
All right. Now, this one should be, as I was telling you, should be using financial calculator. Spreadsheet. Nobody using financial calculator to do that. But I'm going to show you how that be done. How that be done. Spreadsheet, I think in my slides, this should have, I have this one. Let me tell you, there is one very important note here, is Excel NPV is not net present value. I'm going to show you how that be done. Now here is my example. For example, in Excel, 0, 1, 2, 3 is the year, right? The cash flow is negative 250, 100, 150. Everybody knows that. Now I'm using required rate of return represent cost of capital interest rate, 8%, right? So I calculate NPV. Now here's label. Now if I'm using NPV, if my equation, the NPV here, we say the NPV, when you get NPV, it tell you, first one you need put the interest rate in it. B4, yes, B4, see that? It's correct. But next step is from B2 to E2. It's wrong. If I do that, it can be answer 4732, which is wrong one. It should be using this, 51.11. Now how do I using that? So net present value, the whole thing net present value should be using this formula, is equal to NPV D4, interest rate, and the range from C1, from C2, the cash flow 1, to cash flow E, 50, 100, not the first one. Then you plus the first investment, since you are using negative sign, you plus. Okay? You must correctly calculate net present value to look like this. Equal to, using function NPV, parenthesis, interest rate, location, range from cash flow 1. Then you add initial investment. So why they do that? For some reason. They stick with their wrong formula. From the version 1, in how many years? 20, 30 years ago. You see, it's the wrong version. For some reason, they don't want to change it. It's still using that. So Excel NPV is not net present value. Excel NPV is a present value of cash flows. In order to calculate NPV, you have start with cash flow 1, but add back initial investment. Okay? The formula should look like this. I think in your homework assignment there is a one. We'll be looking at it. You cannot just using net present value. And I think there's mistakes. I have no idea why Microsoft never changed that. Okay? We never changed that.
Why would they continue that as being?
Because that function is they bought it from some kind of third party. All those financial functions, they bought it from a third party. They provide that. The third party, the massive, they never change it. They didn't change it. But since everybody knows that way, we just so every time we have using that present value, we have to caution your when you do your homework.
That's crazy, being it's such a large part. Of
I know. Yeah, then this is for some reason, right? So the second component is range of cash flow. We're beginning with year 1, not year 0. Okay. So the correct answer should be NPV plus initial investment. Add to the back. The reason I'm using add because I put negative sign in front of cash outflow. All right. Now, one method, quite a popular, particularly in many business situations, is the payback period. Like in system investment, I met some friends, they open restaurant, they open Starbucks shops, and invest. How long will it take you to get the money back, right? We had a year ago, we had this MBA course this year. We have a gentleman run a catering, some kind of Japanese catering shop in Somerville. So one the investment, it did take like 2 years. Wow, that's long. The investment take 2 years to recover. That means kind of long. Usually, take people less than 1 year. You should have the investment, coming back. So, how long does it take the project to pay back? That's the number of year, in terms of year, to pay back. Now, in order to do that, we have to do a calculation. You literally have to do calculation. We don't have a formula. We don't have like a function key to do that. For example, like the old example here. Using my old example on payback period, right? Yeah. Now, 0, 1, 2, 3, those are the cash flows. You can write it down. Now you create a new column, call it cumulative cash flow. This will record how many. So initially you have 200. The end of first year, since you have positive cash flow 50. 50 plus 200 to get negative 150, not recovered. Next one, 100, you get 50 not recovered. Obviously, next cash flow, you don't need the whole year. How much? I'm using what the remaining divided by the total cash flow on that particular year. We have 1/3. So the payback period in this case is 2 1/3 year. 2 1/3 year. So basically, just looking at how many you can recover. Now, what is the criteria for payback period? Is arbitrary. Basically set by management. In most cases, management will prefer a short payback period. For what reason? Why you want a short? Compare all reasons why you will prefer short payback.
Because you can then have use that money.
Yeah, you get money as early as possible. It's safe, particularly when high uncertainty situations. You will prefer short payback period, right? So-called people so-called like a low-hanging goods. Have you heard of low-hanging goods? You want to pick up some projects, low-hanging goods. It's easy to pick, all right? Don't take it too much risk. Yes.
Does it mean that like the interest rate is not so high, you can like to short?
Yeah, it's everything. No matter it's in high interest or low interest rate, it's more of a you want a liquid, high liquid. You get your money back fast. So it's set by management. But this is actually does not consider a very good method. For what reason? You basically totally ignore time value money. Number 2, you totally ignore cash flow after payback period. There's some project, in my payback period, short period, but another project, payback take a bit longer, but they have more future cash flows. So it's not very scientific. It's more or less, it's a totally biased against long-term project. But the advantage of payback period is easy to understand. And the people will prefer a short payback period. That is measurement of liquidity. It's more liquid. Get money back fast. Okay? So this method has some disadvantage. You should not use this method as the only criteria. No, should not. It's like secondary criteria. Calculate its payback period. The faster period, the better. give you a sense, a high liquidity. Now, the discounted payback period, they basically discount each present value. I think it totally wastes your time. Why, if you do discount payback period, we already did the net present value, so skip it, forget it. Now, as for accounting, average accounting return, this one's still used by some accountants, is the average net income divided by average book value. The calculation is tedious and not very useful. Not very useful. So we all skip also. I say we are not using it. Because in real life, people don't use it. In real life, very few people use it. We need to go to is what the people use. Net present value is number one. What is number two? Number two is internal rate of return. That one's another important. By definition, what is internal rate of return? Internal rate of return is the rate of return will make this net present value equal to zero. Right, now let's do the internal rate of return analysis of our project. Let's look at our project which has internal rate of return. So, see this one? We have IRR here. Let's assuming I forgot which one I'm using. Net present value. Yeah, this is the second example I put it in, right? So I still have second example in it. So I'm using internal rate of return. Just punch compute. It's very quick calculate, 24.14. Second example, 24.14. So the calculation with the calculator is very easy. You just enter all those cash flow by punch IRR and compute. 24 something. Now, what is the criteria then? The criteria is IRR should exceed the required rate of return. What is our required rate of return in this case? 8%, right? The representing cost of capital. This one gave you 24. So 24 is higher than 8 if you accept this project. Okay? So you accept. Now, how about ranking? Ranking. The ranking criteria, you choose in the high IRR. High IRR, the better the return. IRR has, let's do one example on IRR. Now, mathematically, the calculation of IRR is pretty tedious. If you do it, if you use mathematical method to do it, you have to using try and error. You try to find IRR which make this one equal to 0. But the calculator do it much faster. You don't have to try it and error. You directly solve the interest rate will make this one equal to 0. Now, there are certain for example, you enter, early example, enter all those cash flows and you directly compute IRR. Example 1, IRR is 19. Cost of capital 8%, you accept this project. Now let's look at what IRR really means. IRR is that interest rate higher than that one, your net present value will become negative. Lower than that one, your net present value will be positive. So IRR is at that rate, the net present value exactly equal to 0. This is what we call NPV profile. Now, this project, if the discount rate is 0%, it has a value of 100. As the discount rate increase, going down, to a point at the 0, that portion, 19.44, not approach 20 yet, is the rate which you are make net present value equal to 0. That is by definition is internal rate of return.
So any project above that is profitable and any below it is not?
Yes, but this one shows you what IRR really is.
So it shows you the discount rate that you,
So this one shows you what the rate of return of this project is. The rate of return of this project, the highest the rate of return of this project is. You compare this one with your cost of capital. Now let's do this one with spreadsheet. As I said, the IRR also should be used in spreadsheets. Spreadsheet. Straightforward. Here is a spreadsheet. Here is a spreadsheet. I'm using different numbers. Initial cash flow is negative 165,000. Initial and cash flow is this one, this 3. Now, let's look at the first one. I'm using the first one. We call it financing rate, or the cost of a capital. We call it cost of a capital. Then we can calculate IRR. The IRR here is 16%. Is 16%. You do a 16%. Very straightforward. Let me show you the IRR formula. The formula, you will see that is IRR is from this one to here, the whole range. The function also will allow you to put a one interest rate as guessing that. Because IRRs later will show you sometimes you can have multiple IRRs. But when you do the calculation, the easy one will be just equal to IRR B2 up to B2 column, then E2, B2 to B2, whole range. The net present value, remember the net present value? Net present value is B4 and C2E2 plus B2. See that? That's net present value. So here is what we call IRR method. Now, I need to move to the second one. We need to looking at the problem with IRR. There are 3 problems with IRRs. So make it not like a 100% every time sure bet. Not like that present value. First one, multiple projects. Now, sometimes project we call mutually exclusive. That means you can choosing one, not the other. Or sometimes projects are independent, it doesn't matter. Choosing one or the other one. You add the other one. Right? Now, in the mutual exclusive situation, you make choices. You always using the rank order alternatives and choosing the high one. If these 2 projects are independent, you take them all if they are meet the minimum requirement. But when it's in a mutual exclusive situation, you have to make choice. The problem is, sometimes the cash flow might not traditional. Now those are, we call the traditional cash flows. Cash outflow, cash inflow. Or something like this. Cash outflow for 2 years, cash inflow. Those are all okay. It only changes sign once. The problem is something like that. Cash outflow, cash inflow, 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 outflow, inflow, inflow, inflow. Those, you are shifting change sign more than once. You are facing what we call the multiple IRR. It's like this, negative 200, positive 200, 800, negative 800. And say, what kind of project like that? I'll give you an example. Nuclear plant. You have initial cash outflow, then you have cash inflow, then you shut down. When you shut down, you have multiple year cash outflow again. You clear. Right. The other one is oil drilling. When you oil drilling, you spend a lot of money initially try to dig a well. After certain production from well, the pressure went down. The oil drilling company need to pump more money into it, put the pressure up. Then we have another couple of years more oil. So you change sign them more than once. In that case, you are solving a equation which has two roots. Why? This in one of the example, in your example homework, example 30. See the cash flow? Positive, negative, positive, multiple change. One change twice. Should we accept this one? Now, in this situation, we have a problem. The problem is, we might have two solutions. What two solution is? You solve this problem, for example, here is the cash outflow. It's quadratic, if it was only two terms. It's quadratic equation. In a quadratic equation, the solution have two roots. X equal to negative b plus minus square root of b2 minus 4ac divided by 2a. So if you plug those numbers in, you find there is one number is negative inside the square root. We know inside the square root that number will not be a normal number. It will become a complex number. In other words, there is no normal solution. The reason is the mathematics. Because if you are solving a problem, it's probabilistic. If you look at the equation. The solution, we say that the IRR is make net present value equal to 0. We have two solutions. One is 0. The other one is 100. Now obviously, if IRR is 100, we accept it. If IRR is 0, we reject it. But we don't know which one is. Now this is a mathematical relationship. It's a mathematical problem. You have multiple solutions. Now this is for quadratic. If we have 3 times, then you might have 3 solutions. You don't know which one is. So multiple IRR is a problem. How do I know it's multiple? When you look at the cash flow, if you find a change sign more than once, here's 2, twice. 1, 2, then you have multiple IRR. So the IRR you get might not be reliable. So when a multiple sign change, you might have multiple IRR. This is one. Reason 1, you might have problems. Number 2 is the scaling problems. Scaling problem, for example, you have a project, 2 projects. One project gives you 100% return, IRR. The other project gives you 50% return. Which one you want to choose? And we choose 100%. But 100% is only require a $1 investment. You get $2. The other one, the investment require $1,000. You get like $500. Obviously, that one is more lucrative. But internal rate of return does not tell you what the scale is. Right? So everything equal, internal rate of return is comparable. But only internal rate of return, you do not know what the scale situation is. This is the second weakness. The third weakness, a timing problem. A timing problem is, let's look at project A and B. What the similarity? All require initial investment $10,000. What between these two? If this one pay back earlier, $10,000 first year, then 1,000, 1,000. This one, 1,000, 1,000, and a huge $12,000. It will depend on, let's think about extreme case. If the cost of capital is zero, if it costs you only $0, which one you will do? You will choose. Which project you will choose? There is no time value money. All the cash inflow is 12,000. See that? But this one, you add them together, 14,000. You choose this. Because it costs you zero money. If time value money is zero, $12,000 is still $12,000 today. See that? $12,000 3 years from now worth $12,000 today. When interest rate is low or approaches zero. On the other hand, if interest rate is high or positive, then people might prefer this. You want your money earlier, because $12,000 much worse, probably less than $10,000 a year from now. The timing pattern will affect, will depend on interest rate. Interest rate. In this situation, if the interest rate is higher than 10.55, people will prefer project A. Get your money earlier. If the interest rate is less than 10.55, people will prefer project B. Because it gives you huge, a large number at the very end. In other words, time value money, when the time cash flow in time pattern is different, sometimes the internal rate of return might indicate a wrong solution. Okay. So if you're looking at internal rate of return, project A is 16, project B is 12 or 13. You will say, we should take project A. No, project A is not always true. If interest rate is very low, then project A actually is worth more money. Now, here indicates internal rate of return might give you wrong answer, but net present value are always correct. Because we always choosing the highest net present value. Net present value are always correct, but internal rate of return might cause you some trouble. Now, how do I calculate those like crossover rate? The book did not tell you. But here in my slides, there's a couple methods you can do. You list project A, project B of its all cash flows. Then you just using this one minus this one, this one minus this one. It doesn't matter. So I'm using this one minus this one. So the difference is zero. This difference is negative 9,000. But here, $11,000 more. Then you compute, put those things into cash flow, and compute for its IRR. Before this one equal to zero, now this IRR is so-called crossover rate. The crossover rates calculate the difference between A and B and compute for its IRR, break-even point. That break-even shows you cutting off period. Now, this crossover rate in internal rate of return. NPV versus IRR. in 90%, even 95% of cases, these two criteria give you exactly the same thing. Indication. In other words, net present value positive, IRR also give you indication is higher than cost of capital. But there are 5% chances due to exclusive cost of capital, time pattern, scaling. Sometimes it might give you wrong answer, particularly the multiple IRR is a problem. In that case, what we do, always go with NPV. When you do the calculation, you calculate both of them, NPV, IRR, and report them. Even IRR below cost of capital. But you always go with net present value. Net present value should be correct. It should be the highest one, choosing the net present value as the highest one. Now, let me also introduce you to one more, for some reason I put this one more method. It's called modified IRR. In other words, the IRR, sometimes people find out they're assuming cost of capital is equal to the reinvestment rate of return. What is reinvestment? For example, you have multiple cash flows. Now those cash flows you receive, for example, 50, the first period, you received it, then you reinvest in the project, which earns the same required rate of return. This is the assumption. The reinvestment of like $50, $200 somewhere here are reinvest at the same rate. But in real life, the reinvestment, all the cash flow are not necessarily will be invested at initial financing cost. You might invest in a different way. How do I do that? That one is called modified internal rate of return. Now here is a particularly there's a website, but I'm going to go back looking at my early IRR message. Now here is a method called MIRR. I forgot if the book mentioned this or I added. I think probably I added.
I don't think the same thing.
It's not in the book. But it's widely used in practice. It's called using MRR. What the difference is? Formula-wise, MRR is a built-in Excel function, MIR. First, you give you range, B2 to E2. B2 to E2. Then, the first one, B4, is the financing cost. Initial borrowing cost, or discount rate. B5 is what we call reinvestment rate. Now, you can assuming these two rates different. So, the borrowing cost 12%, you reinvest at 24. You're assuming, sometimes you're assuming this rate is higher than this rate. In other words, it will give you a different MIR, different IRR, because you're assuming two different rates. Now what that is, that gives you some kind of leeway to manipulate your number. To manipulate your number. For example, let me just give you a hypothetical example. Your boss gives you a project to evaluation. Your boss really wants this project. So you calculate all those things. You have internal rate of 16%. But your cost of capital, let's say, is 17%. Slightly low. Then your argument is that, okay, we get those projects, but we can invest at a 24, not 12. The cash flow we receive can be reinvested at a high rate. In that case, Your MIRR is 19. See that? Which is much better than the 16. See that? In other words, they will allow you using different reinvestment rate. If you give you the leeways to argue your project. Why I'm using this example? Because literally I have one student who was the VP in equipment for Franklin Templeton. I forgot his name. I still saw his face, but I forgot his name. He just using this method to justify the equipment purchase. They have some equipment purchase for setting up some kind of meeting room with their Florida headquarters and meeting room. You want to have a project, have a much fancier project, and he just using this one. The internal rate seems too low. He's using a reinvestment, high reinvestment for the image, and show you the MRR is high. And give some kind of leeways. You can confirm this project is more put a more favorable light. You're assuming the reinvestment rate is higher than finance rate.
So you're padding the numbers.
Yeah, it's sort of kind of, in real life, it's actually that.
But that's a higher risk thing to do, because typically you go with a more conservative approach with your forecasting.
Right, but you sometimes window dressing is, the budgeting itself, you want the budgeting itself.
So for budgeting purposes, it would be good to use this versus, because then your number is
No,
automatically.
I'll show you this one is, I can give you a number, that one can be high, can be low. So I really don't want this project. I'm assuming reinvestment below this number. See that? So reinvestment actually, although your financing rate 12%, right? I cannot really get a 12% return.
But isn't that risky in and of itself, because the reinvestment rate is down the road, so you can't guarantee.
Yeah, if
that
I put
rate.
a negative, a low number than 12, that number is lower than that. In other words, internal rate of return using MIRR lets you manipulate number. What is that?
You teach us how to cook the books?
No, it's not cookbooks. Because budgeting itself,
No.
planning and budgeting itself is more of telling a story.
It's like sticking bobby pins in a light socket.
Yeah, right. Telling a story. You basically, the number is, but the criteria is still, as I said, criteria is net present value. The net present value should always be positive. I didn't say you cook the books on that, because if you net present value negative, then you're losing money. But using IRR and MRR is more of a communication point. You want to be more favorable light share out. But you have justified, obviously you need to justify. The reinvestment should be high, and this one more positive. Alright, so this is quite common. People using MRR. So why Excel also have this function called MRR. I wrote this one. So compare with IRR, you only use one. It's called a financing cost, or sometimes people call it cost of capital. MRR, you're assuming reinvestment rate.
So do you make sure that you're evaluated on your job on the IRR and not the MIRR?
We use both. Use both. Sometimes some people just, if it is legit for you, obviously NPV is important. But the people not using IRR, people using more favorable by using MIR. If this project can justify, say that reinvestment is much higher than financing.
If you can get that reinvestment rate.
Yes. If the assumption is then, makes sense.
But there's more risk with MIRR.
Why not necessarily? No, in some certain situation, if you can justify, the money I will receive, we can invest in a higher lucrative return, and it's justified.
But that's speculative, that's future.
If you're dealing with all those things that's speculative, budgeting itself is very speculative.
Yeah.
Budgeting itself. Budgeting, as you know, budgeting is not simple. It's just not simple put a number on it. But I think the government shut down, tell you a story. It does not mean in the next Wednesday is last day, right? It does not mean that people, all the U.S. government the debt will be default. Exactly. I think now it's people are crying off so many times. People not treat it serious.
So how much money have they saved in these few days of the
Oh,
government
they wasted.
shutdown?
It's not safe. It's wasted because they are still repaying them. Because retroactively, all those furlough people will be paid, but all the missing. Even Yosemite is shut their door. This is kind of more political gesture. And then the market is not treated serious. No people panic. Oh, you're going to default. No, it won't never happen. At least, I don't think they'll be so stupid. There's small chance that they will do it. Who knows? But the budgeting always like that, in real life budgeting. Because everything is based on projections. Everything is based on projections. So you don't have a projection. Does that mean that U.S. government don't have money? No, they have plenty of money. They're arguing the critical limit of your limit. Then why do we need the limit then? If every year you just lift the limit, and day after day, every year we have like a furlough. Every year we need to argue. Every year the budgeting was one will say no, we need to cut. The other one is. But the budget itself, next week we will study it. There's some cash items put in, sometimes put it out, right? You cannot. I really not totally. I'm kind of little sympathetic about Republicans, to be honest with you. Those guys are not very articulate. There's some argument is, although that they're associated with Obamacare, it's kind of stupid. But we need some control. That does not mean that we don't have any control now. And that ceiling is one type of control. You have to prove that. You have the trade-off. Because some kind of spending you need to cut. The spending can be in defense budget too high. Cut it. Why do we need so many tanks? We cut it. But we need to cut, basically. So the budgeting itself is a planning. And those tools, although I emphasize the investment tool, is to help you to convince your idea. But don't forget, you need to follow the net present value. The net present value should not be negative. Okay, it is negative. The last among all those methods is called, after that we'll take a break. It's called profit index. The last one is called profit index model. What is profit index model? PI ratio is the total present value future cash inflow over total present value of cash outflow. In other words, sometimes it can be rewrite the formula, the PI ratio is equal to benefit over cost. The cost is cash outflow, benefit cash inflow. They are all measured at its present value. So I'll give you some example here. 300, net 300 here. I put some kind of small number up. This time I will reject it. Cost of capital, 8%. Okay? So we're going to basically reject this project. Okay? So 350, 180. Should we accept this project now? How do I calculate that? I'm going to show you how that is done. Obviously, we need to go to the cash flow analysis using CFT. See that? Then clear work. You literally have the clear work. So what do you calculate this one? You calculate present value of all cash inflow. First, we calculate present value of cash inflow. Now, how do I do that? So it's a calculate benefit. So I leave the CF0 as 0. Then move to CF1, CF1. So CF1 here is 50. Enter. Next one is 100. Enter. Next one is 80. Enter. Now remember, I did not enter anything on CF0 because it's negative. Here I only want present value of cash inflows. But I'm still going to using net present value key to do it. So NP value, 8% is your interest rate, we move down. And the compute. Now that net present value, 195.54 is the present value of all cash inflows. This present value represents its benefit. Now what is the cost? Cost is 300. So 195.54 divided by 300 equal to 0.65, which is less than 1. Now since it's less than PI ratio, should be higher than 1. I equal than 1. This one less than 1, so we reject.
So we didn't type in the 300.
Yes.
We do like.
So you just divided it by 300 because the formula basically is present value of cash inflow or over present value of cash outflow. So its present value cash inflow is 195.54. What is present value of cash outflow is 300.
Okay.
So it's less than 1. That means the benefit is less than cost. Benefit less than cost. You reject it. Now this one, net present value definitely is less than. Now this one is very similar to net present value. What is net present value? Net present value, in other sense, is equal to benefit minus cost, isn't it? Net present value is benefit minus cost. Now benefit higher than cost, higher than 1. PI ratio higher than 1. Benefit less than cost, PI ratio less than 1. So it's consistent. PI ratio consistent with the is consistent with the net present value. All right. After this, we'll take it. The practice of capital budgeting. So what do we use? Now, in real life, you need to calculate all of them. That including net present value, payback period, internal rate of return, even MIR and PI ratio. Why is it easy to calculate? Then you base, in most cases, it should be give you the same indication. In most cases, except the payback period. Just report on them. And the analysis should be based on everything. Now, if there is conflict, in real case conflict, then always go net present value. Always go with net present value. Always true. Now, the payback period, the net present value, people say that the most commonly used in industry using positive net present value as a cash budgeting tool is starting with like its late 60s, early 70s, business school use. Before that, then people using payback period, very simple payback. But gradually, you have an MBA program using teaching finance, so it becomes like a main theme. So everybody nowadays want to use that.
So why do they use anything else but net present value?
It's a part of the net present value. There is limitations. Net present value require more information. What is the discount rate you use? What is the estimated future cash flows? It's kind of messy. And the communication-wise, internal rate, I must say, internal rate of return is much simpler than the present value. Why? For example, if I tell you, oh, that's a good project, the internal rate of return is 50%. Wow, that is a good project. You know it's a good project. Because internal rate that high must be high return, you should accept this stuff.
As long as the
So
scale.
much easier. It's much easier to communicate than net present value.
As long as the scale and the timing. and-
Yeah, those are just nitpicking on that. In real life, we don't know. In real life, we don't get. It's a very real situation. You have unconventional cash flows. I told you, it's a very real conditions. Basically, they are consistent, and people like using IRR, using internal rate of return, particularly bankers. They like using one word, what a rate of return is. Although you can pick up the internal rate, sometimes are risky, but in most cases, they're consistent with that. I would say that in real life, I will do that. We will do everything in it. But internally, the control should be on net present value. But when you communicate with the outsiders, the internal rate of return seems like it's a well-accepted project. It's easy, single numbers. This project has a return of 18%. Oh, everybody knows that's a good number. This project has a return like 2%. You know, it's a low return. Right? It's easier.
But then if you're really smart, you ask them what the net present value
Yes,
is.
yes. Internally, but in net present value, they also have assumption on what the cash flow is like. So the moral of the story is calculate all of them. All those rules should be calculated, then use it. And when you communicate, sometimes people will like using internal rate of return. Although net present value is some kind of quite infallible almost. But people when they communicate with particularly bankers, people still like using internal rate of return. All right, let's take a break. When coming back, we'll do some exercise with giving you some number we'll play. Then we are going to start working on half of the sample midterm. All right? 15 minutes break for those who want to have a cafeteria, you still have time to do it.